Hi, everybody. Welcome to Houston Techfest 2020, the virtual edition. Before we get started, I want to make you aware of a feature in the presentation that will make the session more interactive. Please take note of the Q&A in the question mark button in the top right corner of your screen. That will allow you to send questions to our presenter throughout the presentation. We'll be answering the questions as they come in, as well as at the end of the session. Please feel free to post those questions at any time during the session, and that way we can take them as they come. With that said, please welcome Jane Prusakova. Jane will be presenting on thoughts on building software architecture.
Thank you, Eric. Good morning. Hello, my name is Jane, and I'm a big fan of Houston Techfest. I wanted to talk about software architecture with the wonderful audience of Houston Techfest. And as Eric mentioned, this is not a lecture. This is not an instruction. I invite you to think through with me, what is software architecture, what makes it important, and how we can do it better together. This is meant as an interactive presentation. So please don't hold your questions until later, until Q&A slides. I'll tell you a secret, there is no Q&A slide. Put them in, even you are allowed to change your mind later, that's okay. We're just having a conversation. So, why are we talking about architecture? It's generally a way to describe a software system in a way that different constituency of the software project can benefit from. It's hard to describe things, and our ability to describe things actually reflects how much we know about them. Eskimos have 50 words for snow. It doesn't mean there are 50 kinds of snow. There is probably more that Eskimos know about, but they have codified 50 different ideas of what snow can be into different words in the language. By contrast, Italians have one. There isn't that much snow in Italy outside of the very top of the mountains, and maybe in an ice cream cone. Ice is like ice cream. Describing software system is hard. It's even harder to describe a software system that doesn't exist yet. Architecture comes in early in the project where the system hasn't come into existence yet, and it helps it come into existence. I looked up what it takes to be an architect, and the first thing that came up is Kruchten's 4+1 view model. Kruchten is a last name, and it's a fancy way to describe that in order for software system to be understood, you have to address multiple groups of people who think in different ways. You have to communicate your vision for business stakeholders, the development team, people who will support the system, and the most important group, the users. People who will directly deal with it once it's out and live. In order to describe it, you need context and vocabulary. Remember, 50 words for snow. Many systems build their own vocabulary. Every system has its own context. How do we tend to think about a system that's not there yet, where we thought something could be useful, but it doesn't exist yet and nobody has done it before? We tend to go from the process. There is data flow. There are decisions about what people do together and what pieces come into the process. We typically build on what we know now and what we expect to happen based on what we know now. A user comes in, they have a task, they have some information, they want to get to some result. So let's put a cube in the middle and say it'll help them. That'll be our software. This is a very crude way to think about architecture, but every software program out there that looks like that from some level. We've always been there. We've been looking at the new project and we've asked these questions. The data comes from here, and these situations trigger certain actions. Users get to see the data or feel the data or hear the data arranged in a specific way. Users can interact with data and cause changes. And then something happens and results are stored or displayed, usually both, counted in certain ways. All of this can be described together as a flow. Information flows through the system. It transforms based on what comes in and based on the decisions built into the system. And something comes out, usually more data. Sometimes we are trying to evoke emotions. Usually we are trying not to evoke emotions, but compel the user to do something or to act in a certain way. So let's talk about architectural patterns. What we've discussed before it is also architectural patterns. Thinking of software as a box and thinking of software as a flow are patterns. Now we are looking in a little bit more details. We can think about a system as a layered structure. Different layers interact with each other in certain well-defined ways, and things happen based on those interactions. What comes in and what goes out changes. This is simple. This is your standard protocol stack. You interact with the top layer, say use HTTP protocol, and out on the wire there are some electric impulses. You can think of a system in a client-server pattern. That's definitely a favorite in a lot of ways. There is a passive server that sits there waiting for requests with a well-known address or discoverable address, and client knows how to post questions to it. Sometimes there are questions and sometimes there are requests for action. Server affects its own state based on the client trigger. Pipe and filter is one of the ways to think about the data flow through the system. Data is pushed in different directions, filtered, actions happen depending on what shows up there. We can also think about software systems in functional terms. A system can be a broker, enable interaction between different pieces. It can be peer-to-peer, where you have a bunch of similar or identical entities or entities that interact from either side of a client-server paradigm, and they find each other and they do business, whatever that means in the context of that system. There is event pass, also known as PubSub, publishing and subscribing. And then there is MVC, the standard for websites, model view controller. One of the more popular and better used patterns are platform. We used to think of a platform being a hardware box as an operating system, but we've come to expand the term to mean software systems that allow us to do something new and not built in. Facebook has become a platform. There is a gazillion applications running on Facebook. The same is true of many smaller processing engines. WordPress is a platform, so is Android, not necessarily operating system, but the phone itself.
Jane,
By contrast, TurboTax has wanted to become a platform, but didn't manage to. You cannot really build applications you cannot customize your taxes based on TurboTax. That never happened, even though the company once went for such a plan.
Jane, could you explain the diagram that you have up here? It's pretty complex.
Eric, thank you for the question. The diagram here is meant to show complexity. It doesn't show anything specific. There might be a system that looks like this, but I hope it's described better than this picture shows, because this is just a mess. There is no pattern to the picture. Understanding of a pattern allows us to make sense of systems that otherwise look like the mess depicted on the picture. Did I answer your question? Or
Thanks,
did I answer a question of the person who asked it? I hope I did. Please pre-post if that wasn't making sense.
Thank you.
Thank you for the question. So let's talk about architectural patterns. Is it good to use a vocabulary of patterns instead of make up your own? Because you can certainly make up your own. This is a small list, and the full list of patterns is bigger, but it's not huge. Should you be using a pattern? The same question comes for developers. It comes for architects. It probably surfaces in other domains too. It's good to use a pattern because it's well understood. It's easy to communicate because we all have a term for it, a name. And different people will have very similar understanding of a pattern is. It's described in a book. We all learned it. It's some piece of knowledge that's easy to share. A bunch of patterns can be delivered piecemeal. It's not necessarily a good thing in itself, but it's hugely helpful when we are doing software development. It's a cornerstone of doing agile software development. Architecture is not going to be perfect every time. In fact, the opposite is true. Most of the time, architecture evolves. So what we start with is not necessarily going to be great in the end. So it's nice to have pieces available as fast as possible. Pieces that make sense, pieces that work, pieces that can be communicated and acted upon. And another good thing about patterns is they have an original purpose, and they are good for that original purpose. Different patterns evolve for specific problems, and evolution leads to better solutions. So if you have a good fit on the purpose, the pattern developed for this purpose is probably a good fit. That's an easy answer. It helps. The cons are the usual. A lot of patterns are really complex. Platform is complicated. Ours are not that easy too. They can seem easy, but as the plans meet reality, a lot of complexity tends to emerge. Some patterns require big bang delivery style. That's a problem, especially if the system in question is big. You don't want to spend months, sometimes years, before you ever try your system.
So Jane, do you have any recommendations about how much of this we should do up front? How do we decide?
Thank you, Eric. You have to consider at least some of it upfront. Changing a base pattern of a system implementation is expensive. It takes a lot of work, and it's hard to do piecemeal, at least in some cases. When you're picking software architecture, some decisions should be agreed upon by all parties, and that's usually best done before we got started. These decisions cannot be secret because people think in different ways and will come to different decisions. But if this is decided and even more importantly, communicated ahead of the time, you can take advantage of a common vision and get everybody thinking in the same direction. Architecture is usually needed to be decided when a software is built by a team. If it's a single developer creating something, we carry enough context in our heads to be able to pivot easily and to understand the changes we're inflicting. But if we have a team, when you have to talk to other people, when you have to get buy-in and you have to share the details, it's important to have at least some of this up front.
Thanks, Shane.
Thank you for the question. Thank you for speaking up. Okay, so back to the patterns. A lot of the patterns are built to fit a specific situation, and they are hard to expand beyond the original goal. A lot of successful systems go on to have a life that is different than was envisioned by original developers. We all want to be in that situation, and we want the situation to be available as a choice if we find the market fit, if the users like the software, if the market evolves. If a pattern that we got started with is too rigid and too narrow to a specific purpose, sometimes we have to do a complete rewrite and to rethink the system from the ground up. Other patterns are more flexible and you can build things on top, but that's less common. So let's talk about thought patterns. Suppose we are discussing how to build a process, how to build software for our users who want to sell subscriptions to an event, house football for an event. Somebody who wants to, we want to enable our users who happen to have season tickets or who happen to want season tickets for A&M football to book their seats in this complicated time. We tend to think of in terms of data flow. The users know what we want. We have a certain level of a ticket, or we can spend that much money. They know which game they want to come in. They know where they want to sit. They know how much parking they need. So let's enable them to do that. Let them enter what they have. We'll ask them the questions, and we'll enable step-by-step choices of which seat they're going to sit in, how far they should be from other people, where on the stadium we can find spot for them, and how much we're going to have to pay if they choose to go forward with a purchase. That's not the only way to think. You probably studied recursive approach to programming in school. This is #1 topic that undergraduates go through and then never touch again. Recursive is simple if you think about it, but not if you don't and if it's sprung on you. Another topic that is usually covered in a college algorithm class is that of a state machine. We have different states, someone with a ticket, someone without a ticket. How do we get them from from the state with no ticket to a state with assigned seat, with a ticket, with but is paid, that we know everything about where we show up, at what time, where do we park, how much we pay, all of this. I want to talk about how important it is to consider not just how we tend to think, but what software structures can, what ways software structures can be thought of using those less intuitive techniques. Humans and computers are built differently. As humans, we tend to think in linear times. Something happened before something else, and we can reason based on that. It's really hard for humans to comprehend the concept of at the same time, or these things can happen in any time. It's fairly hard to consider multiple options. We just had an interesting problem arise at work because events that used to come consecutive in certain order started to arrive in a different order, even though there is generally no expectations that events should come in any specific order. A bunch of things broke. The cause of this was actually a fix that was a good thing. The team that was working on sending the events, they created concurrency on their side. So now the same events come in not from a single process, but from multiple workers, and there is no synchronization. But it broke quite a bit of clients down the line. It's a popular scenario. Stakeholders handle the most common case. When we discuss with someone how they do their job, they are going to tell us the most typical way when nothing breaks, hopefully the happy option. They do this step, when they do that step, when they process the next event, and then the result happens. It's really hard to get the full tree of decisions that a human makes to achieve anything even a little bit complicated. How does your child get to school? They take a school bus. Easy, right? What if school bus doesn't show up? What if your child is late? What if it's a snow day and there is no school today? What if it's a snow day and there is no school today, but the school bus showed up anyway because they got confused? As humans, we handle these special circumstances with no problem. If we don't handle this logic in software ahead of time, if we don't think it through and implement it, it's not going to be handled. So a lot of the time, software architecture has to allow for this decision tree of special circumstances to exist.
Jane, can you recommend any introductory articles for architectural patterns?
There is a book series that discusses pattern architecture. Unfortunately, I do not have a reference in front of me, but I can send it out. Eric, do I have a way to send it out to all participants?
So the presentation will be on the Houston Techfest site, but if folks would like to send me an email at eric.huckabee@improving.com, and I'll put that in the announcements in the Q&A, I'll be happy to forward that on to you, and you can send it back to me to respond back to them.
Eric, thank you. That's a great idea. I can be reached on Twitter, jprusakova. It will be spelled on the last slide, and I'll post it on Twitter with the link to a presentation. Thank you for the question. So let's consider different architectures. Left is step-by-step, also known as wizard, and on the right is state machine. And this is a particular kind of state machine that's arranged as hub and spoke. Wizard means you can only go to the next step from each point. From home, you go to pick a product, then you select features, then you find out the cost, you pick how many you want, and then you get to checkout. From there is exactly one way out, which is you go home to start over. Hub and spoke is different. You also start at home, but then you can do anything you want. You can pick a product, or you can select features first, or you can jump to select quantity. Suppose you want 6 of something, but you haven't decided what it is. You could probably retrieve price, but unless there is something you picked, it's not going to be very meaningful. But the option is there. You can go check it out, and it'll notice the data. It'll take a note of the data that you have associated with your basket. If prices are there, it'll tell you something. If products are there, it'll tell you something, and if they are not, it may not. Let's consider the implications. This must be a familiar site. This is an IntelliJ new project wizard. Personally, I have spent quite a few days trying to figure out what do I need to select for a product I'm starting. Unfortunately, there is no easy way to navigate through this. IntelliJ changes often, options change often. The problem, I think, is even worse with Eclipse. The problem changes often, and projects morph. Selecting the right combination to start something new is at the top level of confusion, definitely for me, and also for a lot of people I work with. We write very detailed instructions how to set up an existing project in an IDE when we can. And we find that these instructions end up being very fragile because things change. So here is an easier UI. It's actually fairly complicated as far as purchases go. When you're buying a magazine subscription, you have to choose the length of time. Sometimes there is an additional option for auto renewal. Now you get to choose between print and electronic edition. This one doesn't offer electronic edition, it just gives you Kindle. I get my Economist delivered through the Economist app, which is a third option that's not listed here. And the price is shown here for the current set of options, but it will change if you pick something else. I hope you've seen this page, and we can look at it. Yeah. Based on what I choose here, the price is going to vary. I can choose where I want to deliver it.
Jane, we're still seeing your PowerPoint.
Oh, that's a problem. I'm sorry. Let's go back to PowerPoint. Thank you, Eric. Okay, I guess this desktop is not shared. You can choose to put things on the list or to add to baby registry. Can you have an Economist order it for 17 years down the road? I'm not sure. But here you don't have to make a choice and then stick to it. All the choices are laid down in front of you. If you had to go into a separate flow, you'll come back and see it here. I think it's a lot easier than navigating something like this. It should be easier. It's a consumer option, but this is still much better than a lot of subscriptions down the road. So what makes a good wizard? It has to be intuitive, and wizards are built by developers at the time they're building it. It's usually hard to communicate choices from the stakeholders. Developers are notoriously bad at inventing what users are going to want. The answer is let's not do that. The less we define the flow, the better usability the resulting software is going to have. If every path that you can leave open, you should leave open. If a path doesn't really make sense, like getting a price before selecting a product, it should still be open. It won't be very meaningful. It'll tell you, sorry, you have nothing selected, but it's better than not having the option. At least you know it exists. At least the user can tell that it exists. Now, let's look at implementation. What does it take to implement linear flow or circular flow or any kind of flow? You have a transition and you have a context. You have an allowed action, which is defined as only from one state and to a different state. No action is allowed on any state, and there is usually little commonalities in that. Every spot in the diagram allows its own choices. Hub and spoke is actually easier to define. There is some state associated with the current state, and there are all the transitions that are there. Not everything is going to be enabled at all times, but they're all possible from the baseline. So here is a compare and contrast of the two flows that we've seen. Structure it. You have to choose what you can from the menu at hand. If you have to go back, good luck. A lot of the time you have to start over. Or find how to change previously selected options through other ways. The same IntelliJ and Eclipse allow to change many of the choices you picked initially through other menus, which brings more complexity for the user. That's okay, we'll deal with it, it's still hard. If you picked the wrong term on your magazine subscription, you can change it before you go to checkout at any point. You can keep your print or Kindle option, you can pick the length, and change if you want to order in you or not, or which list it should go to. Any choice at any time, a lot easier. So we were talking architecture with developers, and the very first question that usually comes up, well, once I've considered all these architectural issues, where do I start? Because I want to write code and I want to see something work as soon as possible. It's fairly easy. Implement a valid state, then implement another valid state, and then implement a transition. In 3 short steps, you have 3 testable cases. You can look at nothing selected, product selected, and product and term selected. You should have UI, you should have data that corresponds to correct options. You should have transitions that correspond to correct options. And you can verify that all of this works. I think that makes for an architecture that is easy to test early and deliver in small pieces. You can sell a magazine without offering different subscription terms. You can sell a magazine without offering Kindle or print choice. You can sell a magazine with as little or as many options as you'd like. If you wanted to add a hard copy, you probably could. That makes for a very evolvable software. You can implement as little or as much as you wish before you go to market. Things change. We typically face a rewrite because the base architectural decisions we made early on no longer support our users as often as every 3 years. That's for major companies and well-known products. Twitter has survived a rewrite. There was a company once upon a time called Netscape. They went through a rewrite, big rewrite of their server and client, very popular client software, and they didn't survive it. The company dissolved. It got purchased by America Online and dissolved into open source effort. In less extreme cases, hundreds of businesses bear the cost of this. It's expensive. Developers do not agree. The people who invested in the first version usually don't like the rewrite, including the users. Users go through a steep learning curve with changes, and users like to keep everything about the original version or the earlier version, and don't like the rewrite. Rewrite seems like we are paying a lot of money to suffer more because the system changed. Yes, it's going to support some things that we need, but a lot of things that already worked now look different. Unfortunately, a lot of rewrites come with requirements. Make the new system do everything the old system did the same way, and then make it do something else on top of it because we couldn't make the old system handle it. This is hard, this is error prone, this is not exactly fun. And then there is Conway's law. Architecture of a software system usually emulates the form of the organization that produced it. If you have 3 teams working on a compiler, you're going to have a 3-phase compiler. If you have 4 teams, you're going to have a 4-phase compiler. People make software that fits them, and developers have more influence on software than users. Number of users doesn't matter. Number of developers and how they're organized does quite a bit. So let's talk about design. I hope I convinced you to consider hub and spoke architecture when you design your next feature or your next system. One of the reasons I advocate for hub and spoke is that you can iterate on design, and it lends itself well for discussion with stakeholders, with users, with buyers, with people who will provide the content, subject matter experts. Some of the states that as developers we envisioned ahead of time are going to merge together, some are going to split, some are going to change in what context they carry. And it takes time and it takes conversations with subject matter experts, with people familiar with the domain from different points of view to learn what it should be, how it's changing over time, because the domains are also changing. If you are going with state machine, it's not that hard to refactor the code. It doesn't amount to anything nearly as big as a redesign and rebuild. It can be done in an agile way fairly easily with a very quick iteration to see the changes. And then there is maintaining architecture. Architecture starts with a clean, beautiful, well, beauty depends on what you like, with a clean, focused idea of what the system is going to be like. But as we go through reality, as users come up with new ideas and new requests, as developers change, people join the project, leave the project, that original structure starts to morph and acquire entropy. You have to keep sharing the focus of the original architecture with the people who join the project. Architectural decisions have to be communicated continuously, even if they were old. We tend to forget. It's especially important to communicate how things are being rethought, why you're changing what you're changing, not just what the implications are, not just what the changes are, but what problems we are trying to solve with updates. And finally, you have to continue talking to stakeholders. What do we not know? It's important for us to understand the domain to make sure that the system architecture represents it well. And domains change too, so stakeholders change. You can get different points of view over time simply because new people come in. These are not books on architecture. These are really good books that everyone should read and have close to their desk on thinking about software. We address different aspects of software development process. There are some essays in the Mythical Man Month that discuss architectural considerations, but it's not a book on architecture. The Pragmatic Programmer by Andrew Hunt and Dave Thomas is an excellent book for every developer, even if you weren't interested in software architecture. Although, of course, you are, otherwise you wouldn't be here. Pragmatic Programmer discusses the logic and the thoughts how we can and should approach software development as a team, with architects, with developers, with users, with stakeholders, with everybody who is interested in the end result and in the path that takes us there. And that's it. Thank you for joining. I can be reached on Twitter. I will be posting the slides and the articles discussing architectural patterns on Twitter. Please follow me. I tweet sometimes, and I appreciate you being here. Do we have any more questions?
Jane, what are your thoughts on whether we need an architect or whether we can do it with a dev team?
That's an interesting question. Thinking about system architecture and being responsible for communicating it to everyone involved in the project is definitely work. Do you need a separate person who does that work? Depends on your team. It also depends on the size of the system. Is there enough work to fill a full-time job? A lot of the time there isn't. And then can anyone on the team to do part of this work in addition to being a developer, a product manager, doing some other contributing work to the software? You can split the role of an architect, or you can have a separate person. You definitely have to consider that there is work associated there. The problem with having a set-aside person who does just architecture, but a lot of the time in practice, I see them not keep touch with the team as closely as they need to. And when they are not doing their job well, but it's really hard to call them out on that. You need software architect, someone who is doing the work of a software architect, but you need them close as part of a team. Thank you for the question, Eric.
It doesn't look like we have any more questions right now. I'm going to give just a couple seconds for any last minute questions to come in, and then we will bring this to a close. While I'm waiting for the questions to come in, I'd like to thank you all for attending today's session. Jane, thank you very much for sharing and making your presentation.
Thank you for having me. Thank you for hosting the Houston Techfest and for attending it. I think it's great that we could meet and have this conversation here today.
I do have one new question that's coming in, and it says, is state similar to class? Should it be small and single purpose?
Well, thank you for the question. And it's a good one. State is not a class. State can be implemented as a class if you choose to. It could be implemented as a composed class if your states are complicated. I would tend to agree that a state should be single purpose. Every state should be distinct from the others. Depending on your field, if you have a lot of states that only vary in a little bit of detail, you can consider implementing them as a single state with a little bit of difference. But if your states are genuinely different and there is a relatively small number of them, then yes, you're going to have a class per implementation. It would be nice to have examples. Let's make up some. If you were considering building a school system where students get to subscribe to classes, you can think of a state as having a class in a schedule. So is it a separate state if you have just Math 101 and a separate state if you have Math 101 and Physics 201? They're probably not distinct enough. You probably want a state where a student has no classes in the basket, some classes in the basket, and full schedule. Those would be distinct states, and they can be implemented as a single class, single base class with different context. With in one case, you'll have full schedule, which means the students cannot go pick any more classes, or empty schedule. They must pick classes before they do something else. Or they have some classes but not a full schedule. They can check out or they can pick some more. So those would be distinct states. You could implement them as 3 different end classes, or you can say that it's the same class with different data associated with them.
Thanks,
Does that answer the question?
I think that covered the question, but if the person who asked the question has further, they're very welcome to post a reply to their question, and I'll bring it to your attention. We do have one more question. Do you have a Q&A methodology that you like in the initial phases of a project that helps you determine what architectural pattern to choose, if any?
Do I have a Q&A method?
Yeah, I think they're talking about things like, and forgive me if I'm putting words in your mouth, Mike, things like event storming or brainstorming methodologies that let you start to identify the architectural needs and the design needs.
I don't have a questionnaire for the users. I do find it useful to review the patterns before I get into the conversations, so that I have enough patterns fresh in my mind, but I can let as I begin to understand the domain, as I learn what the customer is talking about, I can map it into something that's fresh in my mind. I don't memorize all the patterns. I tend to think in terms of a few that are competing in my mind for a specific system or feature. It helps to have a broader set on the top of my mind as I'm trying to learn a new field. I prefer to let the users talk about their situations with no prompts. I tend to ask the question, so what happens next? And what if, rather than have specific set of questions that I ask. Any other questions?
So Mike did clarify that he was thinking of things like brainstorming, interviews, etc. We also have a couple more questions coming in as I speak. So Jean asked, is the pattern discussed here for user interfaces or more general?
Thank you, that's an excellent question. The patterns of hub and spoke compared to wizard is definitely more general than user interfaces. Wizards are actually acceptable and necessary in some user interfaces. It's very common in the backend code. And if you look at the code, the wizard looks like a big set of nested ifs and thens. Depending on what choice you made earlier, you're presented with different choices. If your code is full of if statements, you're dealing with a wizard. I find this kind of code very hard to read and very error prone. We see a lot of bugs there. Hub and spoke means smaller ifs, less choices, and a lot less nestedness. I prefer to write code where my if statements are like guard statements. If this, then do that, and when that if closes and that decision is made and that branch has been serviced. Usually you just exit and go to a different location to handle the remaining business logic. So hub and spoke is we are in this situation, so we are going to take the following actions. We are not going to handle the rest of the situations here. This is going to live elsewhere. The patterns definitely apply in the code, in how you think about the system, in how the system is built internally, not just the UI.
I think we have time for maybe one or two more questions. We have one from Bedford here. How do Agile environments and iterations tend to affect the architecture? And how do you mitigate these changes effectively?
Agile environments are fast moving, and that's a good thing. We want quick iterations, we want changes that show up quickly and in small chunks and are testable. It's important that the changes that are being made to the system agree with the original idea, but the system stays coherent. It prevents bugs, sometimes future bugs, sometimes very current. As you put things in, something else is breaking. That's very common. And the way to make sure that the changes that an Agile team very quickly, without consulting with an architect somewhere outside, makes to the software is to make sure developers are aware of what the architectural decisions are, what is the underlying structure, what's the original thought, and what are the reasons for the architecture being chosen the way it was. For example, if we want to model our system on an event bus pattern, if we have multiple components that are sending events and picking up events and reacting to them. And then somebody comes in and says, well, I'll just create an API over here and other components can connect to me over an API. Is that a good decision? It depends. It's definitely a decision that goes against the original architectural setup of the system. Sometimes you want to break it, sometimes you don't. It definitely warrants a conversation with the team if you should do this in this particular feature request. Thank you. That's an excellent question.
Thank you again, Jane. I think that we will probably wrap up at this point. This has been Jane Prusakova with Viasat. Thank you again, Jane, for presenting. The recording of this session will be available at HoustonTechFest.com soon. So we hope that you enjoy the rest of virtual Houston Tech Fest and have a good day. Thank you again, Jane.
Thank you very much, Eric. Thanks for having me. Thank you everyone for joining.